Welcome to this lesson on periods in the periodic table. Today, we're going to explore the horizontal rows of the periodic table and understand what makes them so important. These rows, called periods, reveal fundamental information about the structure of every element. So, what exactly are periods? Periods are the horizontal rows in the periodic table. If you look at the table, you'll see it's organized in rows running from left to right. These rows are numbered from 1 to 7, starting at the top and moving down to the bottom. Each of these 7 rows represents one period. Here's the key connection you need to remember. Each period represents the number of electron shells an element has. The period number tells you exactly how many shells of electrons surround the nucleus of that atom. This is a fundamental relationship that helps us understand atomic structure. Let's look at some examples to make this clear. Hydrogen is in period 1, so it has 1 electron shell. Carbon is in period 2, which means it has 2 electron shells. Sodium is in period 3, so it has 3 electron shells. Notice the pattern? The period number directly tells you the number of electron shells. Now let's examine all 7 periods. Period 1 contains only 2 elements. Period 2 has 8 elements. Period 3 also has 8 elements. Period 4 expands to 18 elements. As we move down the table, the periods generally contain more elements because atoms can accommodate more electrons in their outer shells. Continuing with the remaining periods, period 5 also contains 18 elements. Period 6 is much larger with 32 elements. Finally, period 7 also has 32 elements. The increasing number of elements in later periods reflects the growing complexity of atomic structure as atoms gain more electron shells. Why does this pattern matter? As you move down the periodic table from one period to the next, elements gain more electron shells. This makes atoms physically larger because the electrons are farther from the nucleus. This increase in size affects how elements behave chemically. Elements in the same period have the same number of shells, but they behave very differently because they have different numbers of electrons in those shells. Let's summarize the key takeaway from this lesson. The period number equals the number of electron shells. This simple relationship is fundamental to understanding the periodic table. Whenever you see an element's position in a period, you immediately know how many electron shells it has. This knowledge helps predict an element's size and chemical behavior.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.